electronics. Today's video we are going to do the formula revision of two-port network parameters, that are Z parameter, Y parameter, H parameter, G parameter, which is inverse H parameter, and ABCD parameter. Okay, so we'll be discussing all the equations for these parameters, and I really hope that you cannot really find these parameters all together in a single video anywhere else in YouTube. Okay, so this will be really useful for you if you are preparing for any competitive examinations. It is really time saving. Okay, rather than just watching single videos for each parameters, I've clubbed all the parameters together in this video. Okay, now we are going to see about two-port networks. What is a two-port network? A two-port network means it consists of a pair of terminals at input side and pair of terminals at the output side, and these two pair of terminals constitute input port and output port. Okay, so that is a two-port network. Now the parameters, these parameters are actually various terms that relates the voltage and the current of this two-port network. Okay, we'll be seeing about various parameters individually, but just know that these parameters actually relate the voltage and the current. Okay, so they are actually used for characterizing the properties of two-port networks. Okay. Also, what is the use for this two-port network? Why are actually we discussing about two-port network? We know that in network analysis, various big networks can actually be reduced to or deduced to two-port networks with only an input port and an output port. Okay, and hence we can write the equations for various current and voltages and various parameters of this two-port network. And if you know these parameters, we can write the properties, or we can analyze this two-port networks, which we actually got by deducing a larger network. Okay, so that is an importance of two-port network. And these parameters are actually, as I said, is used for analyzing the property of a two-port network. Okay, so from today onwards, we'll be doing various videos for network, various subjects, various topics for networks we'll be doing throughout this week, along with the mock test series of ISRO Technical Assistant. Okay, so this is the first part of your network series. Okay, so let us see various parameters nextly. First, we are going to see about Z parameter, then we'll be seeing Y parameter, then H parameter, and then G parameter, and lastly, we'll be seeing about ABCD parameters. Okay. Parameter is also called impedance parameter or open circuit impedance parameter. Okay, please note it down. Z, we generally use Z for representing impedance, right? So it is impedance parameter, or it can also be called as open circuit impedance parameter. Why? Because I'll tell it later. Okay, just know that it is Z or impedance parameter, or can be called as open circuit impedance parameter. Now the matrix form representation of this impedance parameter is V1 V2 column matrix is equal to square matrix Z11 Z12 Z21 Z22 into I1 I2. Okay, here V1 and V2, which are the input voltage V1 and output voltage V2, are the dependent variables, and we are going to write equation in terms of Z parameters and I1 I2. Okay, and the equation is right here. V1 equal to Z11 I1 plus Z12 I2. You don't need to by heart anything, just study this. V1 V2 equal to Z11 Z12 Z21 Z22 into I1 I2. Just take the product matrix multiplication, you will get this equation. V1 equal to Z11 I1 plus Z12 I2. Similarly, V2 equal to Z21 I1 plus Z22 I2. It's not difficult to study, right? It is very easy to study. Now, we can represent Z11, Z12, Z21, Z22 in terms of voltage and current, right? Now, how to find, I'll tell for one parameter, that is how to find Z11. Z11 is along with I1, right? So, you have to make the next term, that is Z12, I2, 0. For that, make I2 as 0. So, when I2 is equal to 0, means I2 is present in which port? I2 is in the output port, right? It is here. So, when you are making I2 as 0, means you are open circuiting the output port. Okay, so that is the concept. Then you will get that when you open circuit your output port and you make I2 as 0, this term vanishes. Then the equation will be V1 equal to Z11 I1. Then you can find the value for Z11. which is equal to V1 by I1, right? So that's it. So that is a concept for finding the value of Z11. Okay, see here. Z11 is called input impedance. Z11 means it is the input impedance when output is open circuited. That is I2 is equal to 0. So output is open circuited. We know that when current is equal to 0, it is open circuit. When voltage is equal to 0, it is short circuit. Okay. So here we are making I2 as 0, means we are open circuiting the output, and we'll get the value of Z11 equal to V1 by I1. Very simple, right? Similarly, you can find the value of Z12 here. Z12, where it is? It is here. So you have to make this term as 0. So I1 has to be 0. So open circuiting input port. So this is the equation for finding the Z12. Z12 equal to, and this Z12 is called reverse transfer impedance. Okay, when input is open circuited. The equation is Z12 equal to V1 by I2, where I1 equal to 0. You don't need to study any of these equations, as I am telling it again. Just study this matrix. You can write the equation from the matrix. Then for finding the value of or equation of parameters, just make the term associated with that term equal to 0. And for that, make the corresponding term, whether it is voltage or current, that to 0. Okay. So that's the concept. So the equation for Z12 is V1 by I2, where you are making I1 is equal to 0. Okay. I1 is equal to 0 means you are making the input port as open circuit. Next is the equation for Z21. Z21 is present in the second equation. So you have to make I2 is equal to 0, right? I hope you have understood this concept of making the equations for Z11, Z12, Z21 similarly from these two main equations. Okay, so Z21 is equal to V2 by I1. Okay, V2 by I1, and you have to make I2 is equal to 0. So you have to open circuit the output port. So Z21 is called forward transfer impedance. Z21 is called forward transfer impedance. Then Z12 is called reverse transfer impedance. Okay, so you can relate these terms and you can study so that it is easy for you to remember. Okay, so Z21 equal to, it is a forward transfer impedance when output is open circuited. That is, when output is open circuit means the current is 0. So Z21 equal to V2 by I1 when I2 equal to 0. Next, Z22. Z22 is the output impedance. Z11 is the input impedance. Z22 is the output impedance when input is open circuited. Okay, so the equation is Z22 equal to V2 by I2 when I1 is equal to 0. So for studying the Z parameters or the impedance parameters, you only require these metrics. You need to remember this matrix product. That is V matrix is equal to Z matrix into I matrix. You have to study this. All the other terms you can study or you can write from this matrix multiplication or the equation which you form by multiplying the matrix. Okay. And also in the beginning we have discussed that this Z parameter is also called open circuit impedance parameters. I hope that you by this time could have make out that how this is also called open circuit impedance, because we are open circuiting the ports. We are making the current terms equal to 0, and hence we are getting the various parameter equations, right? So that's why we are calling these as open circuit impedance parameters. Okay, so this is Z parameters. Next we are going to see about the Y parameters. Discussed about Z parameters. Next is Y parameters. So Z means impedance. Impedance means voltage by current. Impedance or resistance is the ratio of voltage by current. We know that, right? What is admittance? Admittance is the ratio of current. It is the reverse of impedance. So it is a ratio of current by voltage. Have this thing in mind. We are going to discuss about Y parameters or the short circuit admittance parameters. Okay. So again, we can have a matrix form representation here. I1, I2 equal to Y11, Y12, Y21, Y22 into V1, V2. Okay, here you can see we are writing equations for current. And we are writing it in terms of Y and V, or admittance parameters and the voltage. So we'll get two main equations, which is this: I1 equal to Y11 V1 plus Y12 V2, and I2 equal to Y21 V1 plus Y22 V2. You don't have to study any of this. Please study this matrix form only. Okay. Here, just take the product Y11 into V1 plus Y12 into V2, Y21 V1, Y22 V2. Right. Then, similarly, which we have the method which we have done for Z parameters, we are going to apply here also. That is, if you want to find the equation for Y11, we'll make this term as 0. So for that, we'll make V2 as 0, right? So if we make voltage is equal to 0, means that we are going to create a short circuit there. If you are making current as 0, we are creating a open circuit there, which we have done in Z. Okay. Now we are going to make voltage equal to 0, that we are going to make short circuits. Okay. So first, let us see what is Y11. Y11 is called short circuit driving point admittance for input port, or you can say it as short circuit driving point input admittance. That is equal to Y11, and that is I1 by V1, where V2 is equal to 0. I hope you understood how to write this equation from this main equation. Okay. Similarly, we'll get the equation for Y12, which is called short circuit reverse transfer admittance. For impedance, it was reverse transfer impedance. This is admittance. Okay. So it is Y12 equal to I1 by V2, and where V1 equal to 0. Okay. Here we are making V1 equal to 0. Then next two parameters are Y21 is called short circuit forward transfer admittance. This is reverse transfer. This is forward transfer admittance Y21, that is I2 by V1, where V2 equal to 0. This also you can write from this main equation. Last one is Y22, which is the output admittance. Short circuit driving point output admittance Y22 equal to I2 by V2, where V1 is equal to 0. So these are the equations for Y11, Y12, Y21 and Y22. Okay, so these are very easy to study, and I'm telling you, if you're preparing for any competitive examinations, this is a time you can make a very nice and short note for two-port networks parameters. Okay, you can make a very brief note of these parameters by using only these equations, and then start doing problems. And while doing problems, you may encounter a lot of questions, and then you can refer this short note rather than studying from this vast subjects or textbooks. You can make very neat and short notes, and which you can use for your reference purpose while you do numericals. Okay, so that is a very practical method of attempting questions on preparing for competitive examinations. Okay, so this is the Y parameters. Next, we are going to see about hybrid parameters or H parameters. Next, we are going to see about hybrid parameters or H parameters. These are very, very useful. Okay, please make a note of this. It is very useful for you. Now, this hybrid parameters, earlier we were only writing the equations for either voltage or current. But now we are going to write the equation for V1 and I2. V1 is the input voltage, I2 is the output current. So here V1, which is the input voltage, and output current are the dependent variables. And we are going to write the equations for V1 and I2 in terms of this hybrid parameters and I1 and V2. Okay. So the matrix form is V1 I2 is equal to H11, H12, H21, H22 into I1, I2. Please study this, and that is the only thing which you require. Okay. And if you write this in the equation form, you will get V1 equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. So this is obtained just by doing matrix multiplication, as I have said earlier. Then for various parameters, that is H11, H12, H21, H22, if you write the hybrid parameter coefficients, these are actually coefficients. Okay, so if you write the value for coefficients, H11 is equal to V1 by I1. See here, we are making V2 is equal to 0. See here, V2 is equal to 0. So if V2 is equal to 0 means we are going to short circuit the output port, right? So this is that is H11 is called short circuit input impedance, right? Why it is called input impedance? Because you can see here, this is the ratio of V1 by I1. V1 is the input voltage, I1 is the input current. And if you take the ratio of V1 by I1, what will you get? It is nothing but impedance, and it is the impedance of input port, okay? And that is obtained by short circuiting output port. So that's why it is called short circuit input impedance. Okay, I hope it is clear. Next one is H12. H12, here you will make this term 0. So you will be getting V1 by V2, right? So H12 is V1 by V2. So it is a ratio of voltages, right? It is a ratio of voltages, or you can call it as voltage gain. But it is not V2 by V1. It is V1 by V2. Okay, so it is called reverse voltage gain. Okay, and here in order to get this H12, you have made I2 is equal to 0. That is, you have created a open circuit, right? So this is called reverse open circuit voltage gain. I hope it is clear. So here we are actually calculating a voltage gain, but it is a reverse voltage gain, and we are getting by open circuiting the output port. Similarly, next one, H21 is I2 by I1. So I2 by I1 means I2 output port current by input port current. So it is a direct current gain. So it is a forward current gain, and we are making a short circuit to find it. So forward short circuit current gain. Okay. So if it is I1 by I2, then we would have called it as reverse current gain, right? But here it is H21. I am telling how the name is coming. Okay. H21 is I2 by I1, where V2 is equal to 0, and this is the forward short circuit current gain. You don't have to think much. You just have to study this is this. H21 is called forward short circuit current gain. Okay. Then H22 is open circuit output admittance. See the ratio here. H22 is, it is actually I2 by V2, not I1 by V2. Okay, sorry. There is a small correction. If you have already noted, please change it. It is I2 by V2. So it is open circuit output admittance. Since it is a ratio of current by voltage, it is admittance. And since it is output current by output voltage, it is output admittance. And we are making a open circuit in the input port to find it. So it is open circuit output admittance. Very simple to study if you actually study without just by hearting. If you understand the concept and study, it is very easy for you to remember. Okay, so that is H parameters. Next, we are going to see inverse H parameters or inverse hybrid parameters. Next, we are going to see about inverse hybrid parameters. It is actually the inverse of hybrid parameter. So you can actually relate hybrid parameter and G parameter or inverse hybrid parameter. In case of hybrid parameters, if you write equation for admittance, here it will be impedance. If there it is impedance, here it will be admittance. Okay, there if forward current gain is there, here will be reverse current gain. Voltage gain, if it was reverse there, here it is forward. Similarly, it is an inverse of it. Okay, now the matrix form representation is I1 V2 equal to G11 G12 G21 G22 into V1 I2. So here the dependent variables are I1, which is the input port current, and output port voltage. There it was V1 I2, right? Here it is inverse. Now we are directly going to see the values of G11, G12, G21 and G22. G11 is obtained by making I2 is equal to 0. I2 is equal to 0 means we are open circuiting the output port, and this is the ratio of G11 is I1 by V1. It is input admittance, right? Very simple to study. Then G12 is, here it is. We are going to make V1 equal to 0. So we are going to create a short circuit. And what it is the ratio of I1 by I2, right? So I1 by I2 means it is the current gain, but it is a reverse current gain. Since it is I1 by I2, it is a reverse current gain. Next, G21 is equal to V2 by V1. V2 by V1 means it is the voltage gain. It is not reverse, it is forward voltage gain. And V2 by V1, right? It is a forward voltage gain, and we are going to create I2 equal to 0, or we are going to make I2 equal to 0. So it is a open circuit forward voltage gain. Last one, G22, V2 by I2. Okay. G22 is equal to V2 by I2. V2 by I2 means it is what? Impedance, right? It is the output impedance, and it is created by making V1 is equal to 0. So we are creating a short circuit. So it is a short circuit output impedance. Very simple. I'm telling it once again, don't by heart any of this. Just have a matrix form representation, because if you start to by heart these things, it is very, very difficult for you, because a lot of equations are there. V1, I1, I2, V2, the ratios. It is very confusing. Only study the matrix form. That is my advice. Okay. If you ask me how to study, I'll tell you only study the matrix form. From the matrix, you can have the equations. From the equations, you can write the values for G11, G12, G21, G21. Similarly, all parameters. Okay. And also, if you have a logic, you can write I1 by V1 as admittance, V1 by I1 as impedance, and also if it is V2 by V1, it is current voltage gain. If it is V1 by V2, it is a reverse voltage gain. Similarly for current gain also. Okay. You don't need to by heart any of these equations, only study the matrix form. Next, we are going to see about the ABCD parameters. ABCD parameters, and generally ABCD parameters are used for analyzing of transmission lines. Okay. So this we study in EMT, because we study transmission lines in EMT. So ABCD parameters can be used for analyzing transmission lines or transmission line parameters. We know that transmission line is also considered as a two-port network. It consists of an input side and an output side, and a transmission line in between, right? So it can be represented as a two-port network. Okay, so what is ABCD parameters? ABCD parameters are V1, I1 is equal to, in matrix form, ABCD. So this is a ABCD parameter. So it is a ABCD matrix into V2 minus I2. So there is a negative for the output port current. So the equations will be V1 equal to A V2 plus B minus I2, and I1 equal to C V2 plus D minus I2. Similarly, just like all other parameters, here also we can write the equations. Okay. So first one, we are going to write the equation for A. A is the open circuit reverse voltage gain. So we have to make I2 is equal to 0. It is V1 by V2, and we are making out I2 equal to 0. We are creating an open circuit. Since it is V1 by V2, it is reverse voltage gain. Just like other parameters, here also we say the namings accordingly. Next, B, short circuit transfer impedance. Here it is called transfer impedance because we are writing the ratio of V1 by I2, not V2 by I2. So it is V1 by I2, it is a transfer impedance, and we are making V2 is equal to 0, and there is a negative sign also. Since I2 is negative, there is V1 by minus I2, that is B. Okay, it is a short circuit transfer impedance. Okay, next one, C is open circuit transfer admittance. So we have to make, in order to find C, we have to make I2 is equal to 0, right? So we are creating an open circuit. So and also this is a ratio of I1 by V2. So it is the admittance, it is a transfer admittance. Since it is I1 by V2, it is transfer admittance, and it is a open circuit transfer admittance. Lastly, D is the short circuit reverse current gain. I1 by I2, and also there is a negative sign, right? Since I2 is negative, it is I1 by minus I2. We can write it as minus I1 by I2. And V2 we are making 0. So we are creating a short circuit. So these are the parameters that we are discussing in this video. So these are the all major parameters of two-port networks. And I'm really satisfied while making this video because all these informations I could club in a single video. Many people do search for Z parameters, many people do search for Y parameters, and I'm clubbing all these parameters together in this video, and it is very useful if you're preparing for any competitive examination rather than referring lots of videos. Just refer this video, make the notes of it, do numericals. It is very useful for you. Okay, if you found this video useful, please do give it a thumbs up, and also share this video maximum with all your friends who's preparing for either competitive examinations or preparing for their semester examinations or studying this topic. Okay, and please tell them to subscribe to the channel also. And if you want more videos, you also please do subscribe to the channel. Thanks for watching and keep on watching. And for notes, please do follow the Facebook page of EC Electronics. I'll be uploading videos and then its notes in the Facebook page. Okay, so that's it. Thanks for watching and keep on watching.